Hi there. Today we are going to be reading and highlighting the first lesson of Unit 1, Gravity and Motion. Feel free to take out your lab manual or open it up on Kami. And we'll begin on page 4. Answering questions. Questioning phenomena. Think of the last time you tossed something up in the air. Chances are you could predict exactly what would happen after you tossed it up. Before long, it would fall back to the ground. But did you ever wonder why objects fall back to the ground so predictably? If you did, then you were thinking like a scientist. Asking questions is something that all scientists do. Scientists look for the causes of different phenomena they observe in the world around them. Broadly, science is the search for explanations about the natural world. Scientists use evidence to form conclusions to support those explanations. All knowledge learned from experiments is part of science. Science is part of a larger cycle that includes engineering, math, and technology. The cycle is called the STEM cycle. Engineers apply scientific knowledge to create new technologies that solve problems. Math is a tool that both scientists and engineers use to capture results and communicate those results to others. Using a scientific process. Scientists use scientific process to guide them in developing a replicable experiment as they seek out answers to questions about the world around them. A process is a series of steps designed to meet a goal. There are 8 steps that scientists often follow to answer questions using data from experiments. These steps give scientists a logical pathway to move from a question toward an evidence-based conclusion. Step 1. Ask a question. The scientific process always begins with a question. Scientists look for causes of different phenomena they observe in the world around them. For example, Galileo Galilei was an Italian scholar in the 16th century who would become known as the father of scientific investigation and astronomy. He was fascinated by falling objects and wondered whether different objects fall at different speeds. One question he asked was, do heavier objects fall faster than lighter objects? Step 2. Research the question. Every year, the amount of scientific knowledge grows. Scientists use this existing knowledge to research their question. They want to find out what is already known about their question. Step 3. Form a hypothesis. After scientists have researched their question, they form a hypothesis. A hypothesis is a clear, concise statement that can be proved true or false. This hypothesis is the scientist's prediction based on what is known about the answer to the question. 3 example hypotheses are: heavier objects fall faster than lighter objects. Heavier objects fall more slowly than lighter objects. Heavier objects fall at the same speed as lighter objects. Step 4. Write a summary of the experiment. Scientists then write a summary of the experiment they will conduct to test their hypothesis. The summary should include the basics of the data to be collected, the variables that will be tested, and parts of the experiment that will remain constant in each test or trial. Step 5. List materials and procedure. Scientists then list materials needed and the procedure they have created that they will follow. A procedure is like a recipe. Whenever you use a recipe, you are following a careful and precise procedure that someone else developed. Scientists write down their materials and procedures so anyone can use the same materials and follow the same steps to get similar results. They also want to create a record of their thinking. Step 6. Draw a scientific diagram. They will also draw a scientific diagram. The diagram helps scientists visualize how the different materials will interact in the experiment. Step 7. Carry out the experiment to collect data. Scientists then conduct an experiment to test their hypothesis. An experiment is a scientific procedure that tests if hypotheses are true, false, or inconclusive. Galileo conducted multiple experiments to test the hypothesis that heavier objects fall faster than lighter objects. Measuring the motion of a falling object is difficult. This is because objects fall to the ground so quickly. Galileo realized that he needed to somehow slow down the motion of a falling object. He did this by rolling balls of different sizes down a wooden board that he inclined slightly from the ground. He thought that the balls would roll down the slope the same as if in a free fall, but more slowly. The results of the experiment are data. Data are the measurements and observations gathered from an experiment. Scientists use experiments to look for patterns in the data that suggest a cause and effect relationship, where one thing or event is the result of another. The pattern is something that happens in a regular and repeated way. Scientists design experiments in a specific way with variables and constants. A variable is something you change. It can be a factor, trait, or condition that exists in differing amounts or types. There are independent and dependent variables in an experiment. An independent variable is the variable changed by the scientist. To ensure a fair trial, an experiment should only have one independent variable. The scientist changes the independent variable to observe what happens. For example, in Galileo's inclined plane experiment, the size of the balls was the independent variable. The dependent variable is what happens as a result of the independent variable. In Galileo's experiment, the dependent variable was the acceleration of the balls as they moved down the ramp. Simply put, accelerations are changes in an object's motion. Whether an object speeds up, slows down, or changes direction, it accelerates. Galileo wanted to see if changing the mass of the balls, independent variable, caused their acceleration, dependent variable, to change. During the experiment, the height of Galileo's ramp was constant. A constant is a quality that remains the same in an experiment. Constants allow scientists to isolate one variable at a time to ensure the experiment results are valid. If Galileo changed the height of the ramp during his experiment, he wouldn't know whether the results were based on the size of the balls or the height of the ramp. Step 8. Form a conclusion. After data has been collected, scientists form a conclusion. The conclusion uses data from the experiment as evidence to support whether the hypothesis is true, false, or inconclusive. After conducting numerous experiments, Galileo concluded that gravity causes all falling objects, regardless of size, to accelerate toward Earth at the same rate. And that is the end of section 1. Make sure that you have everything highlighted and move on to the next video.